Alright, hello class. This is 5.3 notes using side, 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 angle, angle, side, angle, 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 side, and hypotenuse leg theorems to prove triangles are congruent. So we talked about all of these in 5.5 to 5.6, kind of just understanding all of these congruency theorems. Now we're just going to understand how to write the proofs for them. So these are your steps. There are 7 steps in order to write proofs. The first step you're going to use is by using the information given, you're going to label your picture. So you're always going to label the picture based on the given information. And then the first statement in your proof should be the first given. So always the first given statement, and the reason should always be given. And so we'll see what that looks like a little bit more. But when I start off with a proof, always give me the given statement and then your reason. So the reason should always be given. Okay? The third step says deduce all impossible information from that given until a congruency. So congruency is reached. So deduce all possible information. That pretty much just tell me, give me all the information that we know based on what's given to us and based on what we know. And then until we are down to the very last bit of it. So 3 and 4 are pretty much giving me all the possible information. Step 5, if you used up all of your givens and the possible information and you do not have 3 congruencies, so if I don't have 3 congruency statements, so 3 corresponding parts and sides, then you need to look for a reflexive side, a reflexive angle, or a pair of vertical angles to get a congruency. So this is not going to say it verbatim. It's not going to be given to you. You're actually going to create these based on what you see. So a reflexive side we kind of talked about. That's where we had sides touching. So this diagonal would be the reflexive side. And vertical angles we talked about before. If I have 2 angles that are crossing, or 2 lines that are crossing each other, the lines or the angles formed across from each other are congruent. So these are your vertical angles. Okay? Number 6 says, once you have 3 congruencies, determine if the triangles are congruent by side, 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 angle, side, or angle, side, angle. So we will at one point use angle, angle, side, and hypotenuse leg, but for now we might just run into these 2. Then our last step, your last statement should be the prove statement. So where it says prove, that's going to be the very last thing that you'll write. Sometimes you won't know the reason yet until it should be one of these, or angle, angle, side, or HL. Okay? So it could be either of those 5 things that we talk about. So let's try our first example. Example 1 says, given AD is congruent to AB. So let's do our step 1, which is to label. So AD is congruent to AB. Then it says DC is congruent to BC. So based on what's given, I've labeled my picture. So let's talk about our statements. You're always writing down what's given first. So AD is congruent to AB, and DC is congruent to BC, and the reasons are because they are literally given to us. Okay? And then our next part, we don't have 3 congruency statements yet, so I need to at least have 3 of them. If it gave me an angle or another side, then I would have my 3 congruency statements. But I'm only given 2, so I have to find my 3rd one. And to find the 3rd one, this is what we talked about, number 5. So I'm going to star by it. I need to look for a reflexive side, a reflexive angle, or a pair of vertical angles. And here I actually have a reflexive side. Anytime I have a shape where there are 2 triangles that are touching, the part that is touching is your reflexive side. Because if I were to redraw this figure, I have AC and AC. AC would actually be congruent to AC if I were to separate these shapes. So that is my 3rd side. So I can say that AC is congruent to AC because it is a reflexive side. Okay? So my very last statement is the prove part. So I'm proving that ABC is congruent to triangle ABC based on which parts do I have. I have a side and a side and a third side. So based on this, I am using side, side, side. That is the reasoning that I have. So that is example 1. I'm going to flip over to example 2. Note you can pause at your own risk. So for example 2, I have AC bisects angle DAB. So bisect actually means something. Bi meaning 2, and sex is probably section. So I have 2 sections, or you can also say it cuts in half. Okay, so if I have AC cuts this entire angle in half, that means that DAC must be congruent to CAB. Note these are congruent to each other. And so that's actually going to be part of our proof later on. Then it says also given, I have angle 1 is congruent to angle 2. Okay, I know these are, they still say they're congruent. I have them overlapped so it doesn't look like one big angle. So statements, let's talk about our given statement. AC bisects angle DAB, and that's given. And based on what was given, we found the possible answer that DAC, so angle DAC, is congruent to CAB. And our reason for that is basically what's underlined. The definition of bisect. Alrighty. And so once I've done that part given by the first given statement. Now I can move on to our second given statement, which is angle 1 is congruent to angle 2, and because it is given. And I can only say that they're given, and that's okay. Now our last part we talked about, every time I have shapes touching, I will have a reflexive side. So AC is my next statement. So AC is congruent to AC because it is a reflexive side. Okay? And then our last statement is our proof statement. So triangle ABC is congruent to triangle ADC because this is where we have to know the difference between angle side angle and angle angle side. When I have angle side angle, that is what this is, because I have an angle and then a side and an angle. The side is in between my 2 angles. So it's angle side angle. If it was angle angle side, I wouldn't have anything in between here. I would have it over here or something. So that's the difference between angle side angle and angle angle side. So moving on to our next example, I have C is the midpoint of BC, and C is also the midpoint of AE. So midpoint sounds very much like the middle. It's very similar to bisector. So I have C is the midpoint of BD. If C is the midpoint of BD, that means C is in the very middle. Okay, so that means that B, C, and CD are congruent. So C is also the midpoint of AE. So that means that these sections are congruent too. Note, these two are not congruent. Otherwise, it would say AE is congruent to BD. That's why these are different, because it doesn't say so. So now I have to prove that triangle ABC is congruent to triangle EDC. So let's start off with our given statement. So C is the midpoint of line segment BD because it is given. And we know that because it was given, we deduced, or we realized that BC is congruent to CD. So line segment BC is congruent to line segment BC. And that is pretty much the definition of midpoint. Okay, so now let's go on to our next given statement. C is the midpoint of line segment AE. And we found that when C was the midpoint, we knew that AE or AC is congruent to CE. So, and their same definitions apply. C is the midpoint of AE. That was our given based here. And then we deduce this by the definition of midpoint. Alrighty. So, we're still down to our last point. We have 2 spaces left. That means we have to find something else. Well, I'm already given 2 of them. I need to still have a third one. But a third one is not given to me, so I have to know if I'm using reflexive side, a reflexive angle, or vertical angles. And here, I note I actually have vertical angles here because they do cross. They cross to make that X or a wide V, so think of that wide V stands for vertical. So, I have angle BAC, or BCA, is congruent to ECD. And that's because of vertical angles. So, I can write my last part of my proof. Triangle ABC is congruent to EBC based on which reasoning? Is it side, 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 angle, side, angle, side, angle, side? Let's see what's given. I have a side. I have 2 sides and 1 angle. So which one has 2 sides and 1 angle? That would be side, angle, side. SAS. Moving on to our next example, I have line segment HY is congruent to LY. Then it says line segment WH is parallel to LF. So I'm going to draw arrows to show that these are parallel to each other. And that means if I were to extend this line all the way, they will never touch each other. Okay? So now I've labeled my picture. So let's talk about the statements that are given. So given, I have HY is congruent to LY, and I have WH is parallel to LF. And those 2 statements are given to me. So I still have quite a few things before I end up with my last statement. So my last statement has to be the proof. Triangle Y is congruent to triangle Fly. I don't know my reason why, and I still have to fill in the in-between information. So let's talk about the obvious. What is a round angle Y? I have only 2 things that are given to me. And so I need to know if I have a reflexive side, a reflexive angle, or vertical angles. Well, this is very much like vertical angles. Remember we talked about that wide V? And so I have vertical angles here. So I can say that angle HYW is congruent to angle FYL because of vertical angles. Now we still have one more space left. I'm still not done here. So when we have parallel lines and we have a line like HL going through it, what is that line called? This line is called the transversal. We talked about that in previous section. So that's the transversal. So if I want to turn this sideways to get a better view, I have my 2 parallel lines and my transversal cutting through them. So I have all these angles here and here. So what kind of angles would H and L be? H and L are actually alternate interior. So they're alternate. This is alternate interior. So they're on opposite sides of each other. And they're inside the parallel lines. So H and L are alternate interior angles. So if they're alternate interior angles, they have to be congruent. So angle H is congruent to angle L because of alternate interior angles, and I did abbreviate. So based on what's given, I have two congruent triangles based on which reasoning? Well, I have an angle, and I have a side and an angle. So ASA. Note that the side is in between two angles that are right next to each other. So side is in between, so I know I have side in between A. Our next example, I have a square, or I have a rectangle. So based on what's given, because my figure is already labeled for me, I have AB is congruent to DC. Okay, I can also note the angles, but I don't have to. So I know our last proof is triangle ABC is congruent to triangle CDA. Okay, we don't know the reasoning just yet, so let's figure it out. So there's something when we deal about right triangles. What are the sides called? The sides are actually called legs. So that's a leg and that's a leg. And the legs are equal to each other. And then I have AC. And we talked about sides touching. So I have AC is congruent to AC. It's because there's a reflexive side. But AC is also something else. AC is a cross. Okay, so AC is also something else. The longest side of a right triangle, or the angle that, or the side that is opposite of your right angle, is always called your hypotenuse. So when I have the hypotenuse is equal to each other, based on reflexive sides, and my legs are equal to each other, my reasoning these triangles are congruent is because of HL, otherwise known as the hypotenuse leg theory. Moving on to the next page, I have example 6. Example 6 says, given AE bisects BD. So AE bisects BD. So that means C is kind of like a midpoint. So DC is congruent to CB. And then I have A is congruent to E. So based on my given, I have AE bisects BD. And so when I have that, I deduce that DC and CB were congruent. So DC is congruent to line segment CB. And based on that, the reason is the definition of bisect. Our next given statement is A is congruent to angle E. So with that given statement, what can I really know about angle C? You guessed it, there's vertical angles. Remember, they start crossing, so that means these two are congruent to each other. So angle DCE is congruent to angle ACB. And the reason for that is because they are vertical angles. So on vertical angles, I write my last proof statement. Triangle ABC is congruent to triangle EDC. And I'm given an angle and an angle, then a side. So I have angle, angle, side this time. Note, it would have been different if I had a side here in between my two angles. But I have the side unincluded right here. So it's angle, angle, then side. Our next example, and our very last example, I've given LM is congruent to NO. And it's already been drawn for us. And angle M is congruent to O. So let's go ahead and write our reasons and given statements. So LM is congruent to NO, and angle N is congruent to angle O. So, but again, I have this crossing motion here, this wide V, so it stands for vertical angles. So I have angle MPL is congruent to angle NPO because of vertical angles. So triangle MPL is congruent to triangle NPO because of angle, angle, side. Note I have two angles, and the side is not included in between them, so it's angle, angle, side. Okay, so when you're going on to the next page, 5.3 is a practice and is considered homework, and then we do the next class period. Thank you so much.